This video is going to be reviewing Checkmate's scan data loader. We're going to be reviewing specifically two items here. Creating color maps from the scan data of the surface information, and then what we're going to do is we're going to actually extract XYZ information from the edge and depth data of the scan for specific features. So what I want to do first is just take a quick look at the data file that we're going to use. We scanned the bottom of the part here, and we've got this text file. And I'm just going to bring this up so you can just take a quick look at it, just to see that this text file contains just XYZ information, scan data. So we've got this file that we're going to load in. So I'm just going to close this for a second. And this XYZ data, scanning the bottom part, was no coordinate system available. This part is sitting in a coordinate system right now, but let me just show you. If we just load in the data without any kind of manipulation towards the coordinate system, I'm just going to select this data file and load in some points from it, and you'll be able to see where it actually lies in space in the coordinate system in which it was scanned. So now if I just do a fit to the screen, you can see we've got all this mess of data down here in the bottom right. So that's the coordinate system in which it was scanned, which is definitely no good for us. So I'm just going to highlight all of this and delete it. So what we need to do is load in the scan data, create a color map and all that, and get it onto the part. So what I'm going to do is I'm just going to go to our color mapping utility, and I'm going to go to our defaults here just to show you a couple of settings here. On the top left here, what we're going to select is a freeform alignment to the part and shape, and this is called our automatic alignment. So we're going to take this all this scan data in, and we're basically going to fit it to the CAD geometry of the part, so we can get that into the proper coordinate system. The second thing that I want to point out here is halfway down on the left-hand side, it says filter facets for point clouds in the view. I've got this part rotated so that the bottom side of the part is kind of facing towards us, and that's the side that's going to be analyzed for the data. And that's important because this is just a sheet metal part. It's only about 2 millimeters thick, so really when the scan data comes in, how is the system to know which side of the part the scan data belongs to? So with this little option, I can actually specify we're just going to apply this scan data to the surfaces that are facing towards me. So that's an important little option to have in there. So I'm just going to say OK. And what we're going to do is we're just going to load in this data. So let's select the command here and grab this OPXYZ whole part file, and we will open that and import in the color map. Now that the color map has been imported, we can see the color deviations from the scan data. To make it a little bit easier, I'm going to create a legend on the side here so that we can see what the deviations represent. So now we have all the information for the surfaces. What we need now is to get the information for the features extracted from the sides and depths of these features. Now, what we've already done is from loading the scan data in from the color map from the surfaces, we've generated a matrix, a transformation matrix, to get the scan data from where it was to getting the color map where it is now. We have a little utility called CMTrans. In this utility, we can load the matrix from the color map. So I'm going to select this button, and by doing that, we have these XYZ axis angle rotations and some offsets. So we've now saved that information, and we can use that information to load in the scan data. As you'll see here, I'm going to load in the scan data. going to select the exact same file. Now when this comes up, we're going to get this option to use the CM trans information, the matrix, but that utility moves CAD data around. So what we're going to do is we're going to do the inverse. We don't want to move the CAD data, we want to move the scan data to the CAD. So we're just going to select CM trans inverse. It will grab the matrix that we've already used, and then what it's done, it's brought in some reporting entities, which you can see little sticks at the center of the feature. That contains all of the information that we need. So ahead of time, I've created some Checkmate labels that contain the nominals for all the XYZs of these features that we wanted to extract. So now all we have to do is fill these labels with the information that we've just generated. Now we have XYZ information, diameter information, true position information, all of this from the features based on the edge, and depth information from the scan.